Hello, third graders. We have been working through chapter 2, which is all about the properties of addition, and we're on lesson 8. So you should open up to page 107 if you have not already done so. This lesson is called Add 4-Digit Numbers. So we're adding 4-digit numbers. Our essential question is, how can place value help me add larger numbers? Okay, we're going to look at our first example. The largest cruise ship can carry a crew of 1,365. What is the total number of passengers and crew that can travel on this ship? Okay, so I've read my word problem once for meaning, and now I'm going to read it again and find important information to underline. The largest cruise ship can carry a crew of 1,365. What is the total number of passengers and crew that can travel on this ship? Okay, now I'm going to read it and I'm going to look for the question in this word problem. Or in other words, I'm going to look for what I need to find out. What am I solving for? The largest cruise ship can carry a crew of 1,365. What is the total number of passengers and crew that can travel on this ship? Well, I see there's a question at the end here. What is the total number of passengers and crew that can travel on this ship? So I know that it can hold 1,365. So what is the total number of passengers and crew? So this is the crew that it can carry. Okay, so now we need to figure out 1,365 plus 4,376 because this is how many passengers we know there are. So how many passengers and crew, if we know there are this many passengers and this much crew, our job is to add them together to find out the total. So the first thing we're going to do before we actually look for the exact answer is to find an estimate, which means we are making a general but educated sort of guess about what the answer could be for 1,365 plus 4,376. So in order to estimate, we have to round these numbers. And here you can see they rounded to the nearest 100. Right, so because I see that the digit that changed here is the hundreds place. So I'm going to look, they looked at 3, which is the 300 in this number. They looked over and said 6 is greater than 5, so therefore we're rounding up. That 3 changed to a 4, or in other words, the 300 changed to a 400, so it became 1,400. Plus, we looked at the hundreds place, looked over, saw that 7 is 5 or greater, so we're rounding up. And this 300 becomes 400, and everything to the right of these hundreds places changes to zeros. So now these are rounded numbers, and when we add our rounded numbers together, that's going to give us an estimate. Because really a rounded number is like pretty darn close to this number, right? So if we add two numbers that are pretty darn close to the actual numbers, we're going to get an answer that's pretty darn close to the real exact answer, right? So that's how we get our estimate. So we could find that, I know I'm going to look at it this way. 1,000 plus 4,000 is going to be 5,000. And I know 4 plus 4 is 8. So in other words, 400 plus 400 is 800. So my estimate for the answer is about 5,800 people. Okay, so now we're getting walked through how to find the exact answer. And our steps are to add the ones, then add the tens, then add the hundreds and thousands. So we'll start with step 1. Add the ones. 5 ones plus 6 ones equals 11 ones. So they're looking at this place value here, the ones, and they're saying this is 11. So we're going to put that 1 here. But we need to regroup that 10 from the 11 because 11 now, just like when we looked at our blocks, it could be, instead of 11 little dots or 11 little cubes, it could be regrouped, and we can take that 10 and move it over here, which is what that 1 is. This is our 10, and now we've left our 1 in this part of our place value, the 1 section, and now we can go and move over and add our 10s. So 1 10 plus 6 10s plus 7 10s equals 14 10s. Regroup 14 10s as 104 10s. So what they're saying is 1 10 plus 6 10s plus 7 10s is 14, but we can regroup because what it is actually 14 10s, and we know that 10 10s is actually the same value as 100 ones. So that's the same thing as 100. So why don't we regroup that 100 and we put that in the hundreds place. So now if I take away, if this is 14 tens and I've taken away 10 of those tens or 100, then I have 4 tens left. So that's what this 4 is here. And now I can add the hundreds and thousands place. I'm going to start with the hundreds place. And I see 100 plus 300 plus 300 is 700s. And now I'm going to move over to the thousands place, and I see 1,000 plus 4,000 is 5,000. So our exact answer is 5,741. So now we're putting it sort of into a number sentence. 1,365 plus 4,365 equals 5,741. The ship can carry 5,741 people aboard. So now I can ask myself, well, I don't know for sure that this is right, but is it reasonable? Well, this is why we made an estimate, right? So 5,800 was our estimate that we made by rounding these two add-ins and finding the sum, 5,800. And our exact number that we got by adding the exact add-ins is 5,741. Now, they're not, they're not within a few or a couple ones, but relatively, considering how large this number is, 5,800 and 5,741, those are pretty close, right? We're only off by a little bit, so this tells me that my answer is reasonable. If my estimate was like 6 and I got 5,741, that's not reasonable at all, is it? Okay, so I'd like you to turn the page to page 108. We're going to do example number 2. So last year, $3,295 was spent on a skate park. This year, $3,999 was spent. How much money was spent over the 2 years? So I've read once for meaning. Now I'm going to go back and read to find important information. Last year, $3,295 was spent on a skate park. This year, $3,999 was spent. How much money was spent over the 2 years? Okay, now I'm going to read to find the question or what I'm solving for. Last year, $3,295 was spent on a skate park. This year, $3,999 was spent. How much money was spent over 2 years? So that's what I'm trying to figure out. How much money was spent over the 2 years? So we know last year they spent this much. This year they spent this much. How much money did they spend in those 2 years? So I know we're trying to find the total money that they've spent. And so I know these are going to be my add-ins, and I'm going to find the sum. So our job is to write a number sentence with a symbol for the unknown. So they've written this number here, they're adding it up, and that is our unknown. We don't know what the answer is just yet. And they're showing us a very cool tool to help visualize adding two numbers up, which is a bar diagram. And in other places, I've also heard this called a part total diagram. So a bar diagram, a model used to illustrate a number relationship, may help you organize the information. So this is one part of our problem. This is another part, and this is the part we don't know. Part total. And they've labeled it last year, this year, and then this would be the total. Okay, so now we're going to add this up to find the sum. Okay, so we're going to start by adding here. And I'm going to start in the ones place. I always start in the ones, and then I work my way to the larger numbers. So I see 5 plus 9. Well, I know 9, 10, 11, 12, 13, 14. I know that's 14, but I can't fit all of that in the ones place because I need to regroup that 10. So 14, I'm going to leave the 4 ones, and I'm going to take that 10 and move it into the tens place value. So now I'm going to add up my tens place, and I see 1 10, 1 10, 9 tens, and 9 tens. So I know 9 plus 9, or 9 times 2 is 18, 19, 20. So there are 20 tens in the tens place, which means that I am going to have to regroup. So this is a little bit different. So because there are 20, that's actually two, there are not 20 tens, I apologize. There are, yes. There are 20 tens in here. So I can't really draw out all of this. It's just what we did in our last lesson. But 20 tens is the same thing as 2 hundreds, right? Because 10 tens is 100. So 20 tens is 2 hundreds. So I'm going to move my 2 to the hundreds place, and I'm going to leave the 0 here as a placeholder because there's no tens left. We've regrouped all of them. So now in the hundreds place, I can add up 200s, 100s, 200s, and 900s. So I'm going to start with the biggest number, 9, 10, 11, 12, 13, 14. So there are 14 hundreds, which means I can leave behind 4 of those hundreds and take 10 of those hundreds, because 10 times 10, or because I am regrouping them into the thousands place. So if I have 14 hundreds, that means 10 hundreds is the same thing as 1,000. So every time you move up a place value, we are increasing the value times 10, right? So that's the important thing to remember here, is that you are able to, we used to call this borrowing, because if I look at this visually, 14, 1, 4. That's what I got when I added up all these numbers. So I'm bringing the 1 over here, but it's really not just a 1. It's 1,000, or 10 hundreds. I'm leaving behind the 400s because I can't regroup that into the thousands place because it doesn't add up to 1,000. Now I'm going to look at my thousands place, and I see 3 plus 3 plus 1 plus 1. That's 3,000, 3,000, 1,000, 1,000. So 3, 6, 7, 8. 8,404. So now to check for accuracy, we're going to use the commutative property to check the answer, which means that no matter in which order you add, the sum is the same. So now we are flipping these two numbers here. So it's going to be 14, 20, 14, and 8. So when I check my answer by flipping these two numbers that we're adding, the add-ins, I get the same answer, which means that I'm pretty sure this was the right answer. So 3,295 plus 3,999 equals 8,404. The unknown is 8,404 people. Over the 2 years, not people, I'm sorry, dollars. Over the 2 years, $8,404 was spent on the skate park. Okay, so now in our guided practice, we are going to add and we're going to check if our answer is reasonable. So I personally like to start by making an estimate and then solving to check for reasonableness. So comparing that estimate to my exact answer. So I'm going to start on the bottom with my estimate. So what I'm doing is I'm rounding both add-ins here. I'm going to start with rounding the number on the bottom. 654. Well, the largest place value I can round it to is hundreds. So I'm going to round my 6, look over to my 5. Is it 5 or greater? Yes, then I'm going to round up. So in other words, 654 is closer to 700 than 600. So I'm going to say my estimate is 700 plus, I'm going to round also to the same place value in the other add-in. So I'm looking at 3 in the hundreds place, 300, looking over to 4. This is 4 or less, so I'm rounding the hundreds place down, so it becomes 3,300. So 700 plus 3,300 equals what? Well, let's see. 700, I'm just going to add the hundreds first. 800, 900, 1,000. So I know it's 1,000. These hundreds add up to 1,000 plus 3,000, which is 4,000. Okay, so that's my estimate, which is like saying, if I were to add these, they're about 4,000. So then let's actually add them and get the exact answer. 5 plus 4, okay, this is going to be 9. 4 plus 5 is going to be 9. 6, 7, 8, 9, 9, and 3. 3,999. Well, that is pretty close to 4,000. In fact, it is only one away. So is our answer reasonable? Yes. We're going to do the same thing with number 2. So first, I'm going to start down here, and I'm going to round to the largest place value. So here I see thousands in both numbers. So that means I'm going to round to the nearest 1,000. So I'm starting by looking at my 4, looking over to the number to the right. Is this 4 or less or 5 or greater? In other words, am I rounding down or up? Well, it's 4 or less. I'm rounding down. So the 4 is going to stay the same. And everything to the right is turning to zeros. So my rounded answer is 4,000. For our second add-in, I'm looking at 1,000 in our thousands place. I'm looking over to the digit to the right, and I'm seeing that 7 is 5 or greater, which means I'm rounding the thousands place up. So the 1 increases by 1 digit, or the value of 1,000, so it becomes 2,000, and everything else turns to zeros. So I'm taking my rounded add-in and my rounded add-in and adding them up. 4,000 plus 2,000, we know 4, 5, 6 makes 6,000. Okay, so my estimate is 6,000. So now we're going to find the exact answer, and then we're going to compare the two. So I see 9 plus 4, okay, 9, 10, 11, 12, 13, okay. 13, well, that can't all exist in the ones place. But I know that in 13 there's 110, so I'm going to bring that 10 over here, and I'm going to leave the 3 ones. And now I'm going to add up my tens place. So I see 1 10 and 3 10s, which makes 4 10s. The 0 doesn't add anything. Okay, now I'm going to move over to my hundreds place. I see that 7 hundreds plus 2 hundreds. Well, I know that 7 plus 2 is 7, 8, 9. So then I know that 700 plus 200 is 900. And now I'm looking over to my thousands place, and I see that 4 thousands and 1,000s. Well, I know 4 plus 1 is 5, so 4,000s plus 1,000 must be 5,000. So our answer is 5,943. Is that close to 6,000? Yeah, it's less than 100 away from 6,000. We're dealing with big numbers, so that is pretty close. And therefore, my answer is reasonable. Okay, so this is some tricky stuff, but it's going to take some practice, and you guys are going to get it in no time. So we are on page 109 now. I want you to do independent practice on page 109. So it's telling you to add and check for reasonableness. So what it's really saying is there are a couple ways we can check for reasonableness that we did in our guided practice. One is to flip your add-ins, just like we did here, and add them up and make sure you get the exact same answer. The other way is to round your add-ins and then add those up and compare that sum, the rounded sum, to the exact sum to check for reasonableness, to see if they're close. So what I would like you to do is actually do the rounding, because I want you to have more practice rounding. So I would like you to round to the largest common place value. So in other words, the largest place value here is 6,000, or is the thousands place, but I can't round this number to the thousands. So I want you to round these numbers to the nearest 100. And then I would like you to add up those rounded numbers, and that is your estimate. And I want you to then add up the exact numbers, so like 9 ones plus 3 ones, 9 tens plus 4 tens, and so on. And then compare whatever exact answer you have with your estimate to check if you are on track. And I want you to do 3 through 8, just like that. And then the next part of this page says to use the commutative property of addition to check for accuracy. So the commutative property of addition was where we flipped the numbers. So here they've done that for us. So the add-ins are flipped. They start with 1,734 plus 2,882. And then they flip that, so you're going to find the exact answer, the sum. And then find 2,882 plus 1,734. So these are the same. The commutative property of addition tells us that even if we flip the order of the add-ins, the answer should be the same. So you're solving both of these, and they should be the exact same answer for 9 and 10. In other words, these should be the same answer, and these should be the same answer. So do 9 and 10 here. And the last part of this page is algebra, which means we're adding to find the unknown. So these are unknowns, these little squares here, which is really just saying we're finding the sum. So you're doing the exact same thing, except for you are going to place these numbers into our place value kind of chart here. So this is our ones, tens, hundreds, and thousands place. So you're going to stack them according to those place values and then add them. And then your sum is the unknown. So when it says the unknown is blank, you're writing whatever sum you got here. The unknown is okay. And I would also like you to do problems 14 and 15 on page 110. And these are word problems. Something that you might find helpful is that they have a tiny little diagram here, which we called the bar diagram, where you have one part of the problem, one addend, another addend, and then your total here. But I also have larger part-whole diagrams where you are writing some part you do know in the problem, another part you know, and then the total. Doesn't really matter. They flip it on the other way around so that the total's on the top. But you might find this helpful. You do not have to use it. All right.